Welcome to today's lesson. So in today's lesson we're going to be doing descriptive statistics. So you're going to need PowerPoint 5, it's descriptive statistics, and PowerPoint 6, and we'll be doing the question examples for both of those as well. So, descriptive statistics is only, if I can get this, is only for quantitative data. So remember, quantitative data is all numerical, and statistics is all about analysing that data. So today we're going to be doing the measures of central tendency, and there's some of this stuff that I'm just going to fly through because you don't need to know everything about it. There's basically three things that you're going to need to remember. There's the mean, the median, and the standard deviation and variability. So most of this we'll be skipping over, and it's in the data analysis stage of this. So we've done our experiment, our investigation. We've collected our data, made sure that it's all reliable, measured the reliability and validity, and now we're coming to the descriptive statistics, and we are going to analyze it and make our conclusions. So we are about to start with the measures of central tendency. So there are two, and sorry, one of them is cut off in this PowerPoint, and these show the central or the average value set of scores. So when it's measured, it shows the typical score for the numbers, because we don't use all of the number in our data set. We only use the middle one. Alright, so here is a... No, I don't want to do... Let's go to
Mom! Stuck on this assignment. It's on mean, median, and mode.
Oh, Cody. We'll take a break for a second and take the trash out, and then we'll get to work on it.
Okay.
Psst, down here. Here you're in a little trouble with your mathematics.
Yeah, your math.
Who are you?
We are the Triple M crew from Guttertown.
Yeah, Triple M.
And if we help you, you can help us.
Yeah, we'll help you.
Got me?
Okay, what do you got?
I'm the mean toad. To get mean, like me, take a set of numbers or data and add them up. Then you count how many numbers you got. After that, you divide the sum of the numbers by how many there are. That is the mean, or sometimes called average. So basically, you add and divide.
You add and divide. You add and divide. The way that you get the mean is you add and divide.
Add and divide. Oh yeah.
Median. I'm the median toad, the one in the middle. You see me? Median, in the middle.
Get on with the median.
Okay. To find out what the median is, you first make your data list in order, from least to greatest. Then, you find what number falls in the middle.
Tell them what happens if there's an even amount of numbers.
There's an even amount of numbers. Circle the two numbers in the middle. Then, add those two numbers together and divide them by 2. In the middle for median. Circle the number in the middle, add and divide by 2.
In the middle. Oh yeah. Last but not least, it's me, the mode toad. What I do is I find the most common number, the most popular, like me, of course. First, I make up my list from least to greatest. Then I see if there are any numbers that are the same. The most numbers that are the same are the mode, like me, the most popular.
Put all the numbers in a line, small to big, you're doing fine. Match the numbers that are the same. When you do it, mode's the name. Only the numbers that are alike. Let the others take a hike.
Mode is popular.
Thanks, Toads. Now what can I do for you?
Just stay green, Cody boy. Stay green.
Yeah, stay green.
Okay. So, they are what we need to remember. So the first, you only need to remember the two. So the mean, which is the average set of scores. So in order to calculate the mean, you add all the scores together and you divide them by the total amount of scores. So there's 1, 2, 3, 4, 5, 6. There's 6 of them here. We add all of these numbers together, which equals 154, and we divide that number by 6. So our mean is 25.6. That is our average number here. And that's all it is. So have a go at this one, and there's some important things to notice about exam sessions like this. It's never going to be hard. So refer to the following table, which shows the resting heart rate of 10 participants in an investigation. The last row of the table shows the sum of scores. So the sum of scores is actually how many they are. They've calculated the 10 points. So all of these added together is 736. In order to then do that, you have to divide it by 10. And what do we do when we divide things by 10? We move the decimal place one place. So all of these are added together. It is 736. And then divide that by 10. We move the decimal place one place, which makes the mean score the 73.6. And it is always going to be that easy in a test. It's never going to be hard. So 10 students were given 1 minute to memorise a list of 20 words, and 5 minutes later they were given 1 minute to recall as many words from the list as they could. Their scores are listed below. For this distribution of scores, calculate the mean. Okay, so there's 10 scores again. The total is 98, and you've got to divide that by 10. What do we do when we divide that by 10? Move the decimal place one place forward, so it's 9.8. There you go. You just need to remember that. And remember that the sum of scores is always going to be at the end. So the second thing you need to know is the median, and the median is the middle score, or the midpoint. So remember, median, medium, middle. It's calculated by arranging a set of scores in order from the highest to the lowest, and the middle score is the median. So when there is 5, you'd use the third number. When there's 7, you'd use the fourth number. But when there is 6 or when there is 8, you would use 2 numbers in the middle and you divide them by 2. So add 6 and 8, which is 14, and you divide that by 2, so your median is 7. Okay, so when there's an odd number, you have to choose the middle number. When there is an even number, you add the middle numbers and divide them by 2. So here is an example for you. So these ones are always going to be a little bit harder because you've got to arrange them. So I'll give you a little bit of time to do that. Where did you find that? Stop licking. That was a dog, if anyone is wondering what is licking me. Okay, so you should have ordered them from lowest to highest, so that gives you this. It is an even amount of scores. And another trick with this too is that you don't actually have to be arranging all 10 of them to be able to give me the median. You have to be starting from, like, you know, the first 6. So that's all you have to do. After the first 6, that's it. You don't need to be listing anymore. Don't waste your time in a test. So we add 7 and 8 together, divide that by 2, and that is 7.5. Here's another one, and I'm going to just fly through this because I need to put some washing out, and who wants to be doing that at 9 o'clock at night? So this is the same question as before, but this time it's asking you for the median. So there's 10 scores, so you've got your middle 2, 10 and 12, add them together, 22, divide them by 2, 11. Your median is 11. Okay, this is a bit of a different question. So a psychologist measures the IQ of a group of Year 12 students, resulting in the following data. So the mean is 110 and the median is 105. And the question is, explain why the median is a more accurate representation of the IQ of this group than the mean. So here, you're going to be looking at the data and which is more representative. So have a look at the numbers along here. Have a look at the mean. Okay, so how many of these are close to the mean? 2 maybe? And this is the median, it's 105. How many of these are close to the median? Most of them. So what you need to be doing is figuring out why. Why has that one gotten bigger? I'll give you a minute to do that. Okay, so if you haven't got there already, your first option is that most of the scores are closer than 100 to 105 than 110, and your second option for that one, thanks for giving me that rubbish, Juno. The second option for that one is that the outlier is there and it is skewed the mean to a higher score. So both of those options would give you the 2 marks to get full marks on that question. This I'm just going to fly through because they are, you should know graphs, so you know that the y-axis is your dependent variable. You know that the x-axis that you can't see because my screen is cutting it off, the x-axis is your independent variable. You know that the graph should start with 0. It shouldn't be anything else, and that's all you really know. So there's line graphs, there's frequency distributions, so we do use frequency distributions. We use the tables, and that's for qualitative analysis, but we're not talking about that now, so we're not going to worry about it. But just remember, we do use these. Bar graphs we use. So we use bar graphs to show our data when it comes time to doing your investigation report. Shows the frequency of a category, and it has separate bars. The bars don't touch. And the axes on X, the categories on the X-axis are separate, because if they are together, then it shows that it is continuous numerical data, that these things along here are continuous, but ours are not, so they're always going to be separate. And then there's frequency polygons. So before you move on, and you can choose to just do this separately if you like, but have a go at this extended response. Oh, that is, do you know? Sorry, this is really, okay. So this is an extended response question. So I want to take the time to give a little bit of an explanation on the extended response. If you don't know it already, you probably should. So an extended response is there's always at least 1 in a test. Sometimes there's 2. They're worth 20 marks. So this question alone is worth 20 marks. There's 4 points per dot point down here. And I know there's only 4 dot points, but there's also 4 points to the language that you use. So are you using psychological language? Are you using a very independent variable, or are you using the variable we change? That kind of thing. So as long as you're using the words that I've taught you, remember your spelling test, then you'll be fine. So this, I'm not going to read this out loud to you because you should be able to do that yourself. So your questions are 2-factor discuss. So discuss, you're discussing all 4 of these things. Discuss 2 factors that may make this an experimental investigation design. Discuss one advantage and one disadvantage of using an experimental investigation design, and discuss one possible interpretation by the psychologist of the results shown in the graph and or on the table above. Okay, so you're looking at those, just focus on those 3 dot points. So you should get at least, I don't know, 6, is that 6? Yeah, you should get at least 16 out of the 20 points. If you know ethics, then go ahead, answer ethics, but don't stress about them too much. Again, have a look at other students in the class's answers, or ask me and come and get me to mark them. So you're doing those 3 questions, and I'm going to move on to the second PowerPoint because I gotta hang my washing out. Okay, so this one is all about variability. The only thing that we're going to get out of this is standard deviation. I forgot it then. Okay, so frequency distributions. You've probably seen these before, and they're separated from normal distribution to a skewed distribution. There's never going to be a question on this. I just need to make sure that you know it. So in a normal distribution, the majority of the data is located around the center of the mean, and it is a bell-shaped curve. This is a perfect curve. That's what we want out of our data. Do we ever get it? No, probably not. The other kind of distribution is a skewed distribution, and this is when the data is unevenly located or clustered to one side of the graph. So it looks like this. It's an imbalanced bell-shaped appearance. It looks like a bell, but it's not a bell. And that's not what we want, and it's likely what you're going to get. So the thing you need to remember out of this is the standard deviation. So there are 2 kinds of ways of calculating variability. I'm going to teach you one way to calculate it, and standard deviation is way too difficult, and they're never going to ask you to calculate it, so I'm only going to tell you how to interpret it. So variability. Low variability means that scores are packed tightly around the mean. High variability means that scores are widely spread from the mean. So if there is low variability, then it means that our scores are all around the mean and that we are good. If there is high variability, it means that they're really widespread, they're not near the mean, and it's not what we want. So range is the numerical score representing the difference between the highest and the lowest score in a distribution, and it's calculated by subtracting the lowest score from the highest score. So in this example here, we subtract the lowest score, which is 1, from the highest score, which is 8. So 9 minus 1 equals 8, so your range in this is 8. There are 8 scores from the lowest to the highest. This is the important part, standard deviation. I'm not going to teach you how to calculate it. You've never been asked to calculate it before, but there are questions that are asking you what it means. So the standard deviation summarizes how far an average's score differs or deviates from the mean, and it's basically about variation. You know what I told you like a couple minutes ago about variation? This is standard deviation. So the higher the standard deviation score, the higher the variability. So high score means that the scores are widely spread from the mean. Your mean is 7 and your scores range from 98 to -20. Okay? So they're not around the mean. High standard deviation means high variability, which means scores are widely spread from the mean. A low standard deviation means low variability, which means that the scores are clustered around the mean. Your mean is 7, your scores range from 6 to 9. Okay, so they're closer to the mean, and this is what we want. We want our scores to be clustered around the mean. So remember, high standard deviation, scores are widely spread from the mean. Low standard deviation, the scores are clustered around the mean. So here's an example here. The following table shows personality scores for extroversion for a group of students. The standard deviation of this distribution is 1.5. So if you're not sure if that's a big or a small number, have a look at the numbers. Are the numbers high variability, so they are widely spread from the mean, or are they low variability and clustered around the mean? So you are describing what the standard deviation of this set of scores tells us about the distribution. So is it high and widely spread, or is it low and clustered? Yes, the answer is low. So the standard deviation is low, which means that there is a clustered distribution of scores around the mean. Here is a different kind of question. So two classes of students are given a standardized intelligence test. Both classes have a mean IQ of 100. Class A has a standard deviation of 15 and Class B has a standard deviation of 2. Explain why it would be easier to predict the intelligence of a student in Class B than it would be to predict the intelligence of a student in Class A. So Class B is 15. No, Class B is 2. Class A is 15. So remember, which is high, which is low. And if your answer is that the lower standard deviation for Class B means that the IQ scores are more closely grouped, then that is your correct answer. Therefore, it is easier to predict if the IQ of this individual student will be closer to the mean because it is a standard deviation of 2, which means they'll be clustered around the mean, and 15 will be widely spread around the mean. Here's another one. Two psychology classes completed their mid-year examination and both achieved a mean of 62 marks out of 100. The following standard deviations were calculated. Class A had a standard deviation of 2.1 and Class B had a standard deviation of 7.9. Describe what the different standard deviations tell us about the distribution of marks in each class. So this question has 4 marks to it, which means you need to be giving me 2 answers explained.
Oh, no.
So you need to explain Class A's standard deviation, and then you need to be explaining Class B's standard deviation. So just pause me and then do your answer, and then I'm going to move on to the question to the answer. So quick pause. Okay, so the answer is scores of Class A are closer to the mean than Class B, and scores of Class B are wider spread from the mean than Class A. These are simple answers. You need to be explaining them to get all 4 marks. So if you gave me this, that's 2. Okay, so we have learnt 3 things that you need to remember. We've learnt way more than that, but 3 things you need to remember. The mean. The mean is calculated by adding the scores and dividing them by how many they are. The median is the middle score. You calculate the median by arranging them highest to lowest, and it is the middle score. If it is an even amount of scores, then you are adding the 2 middle scores and dividing them by 2. Standard deviation is variability. Low standard deviation means low variability, which means scores are clustered around the mean. High standard deviation means high variability, which means scores are widely spread from the mean. Okay, so number 6 has another extended response. So have a read of them. This is a joined one with another Year 12 topic. So there are some questions here that you're going to have to, what the heck is happening? You're going to have to ignore. So I want you to do analyze the results to formulate a relevant conclusion. Discuss 2 factors that make this an experimental design. and that is it. You are doing question 1 and question 2. So you can get at least 12 marks for this question. Okay, so you're doing 2 things from this. You are doing 2 extended responses with 3 plus 2, 5 extended response answers. 5. Have fun.